welcome to another Outcrop video. So what do I mean when I say the rock cycle? What I mean is the transformation of one rock type into another, and back to the first. And basically all the rocks on Earth can transform and change in nature. And so we have our three main types of rock. We have our igneous, here's a piece of Aberdonian granite. We have our sedimentary rock, here is some mudstone, and here we have a metamorphic rock. So, how do you get an igneous rock? Well, basically, the Earth below the crust is full of magma, hot molten liquid. And when this cools at the surface or near the surface, it solidifies, and what that liquid solidifies into is igneous rock. And so granite is an example of where it is cooled slowly, deep underground, normally under mountains. And so you can see the individual crystals, and these will crystallize out of the magma due to pressure and temperature conditions changing. And when we see lava, which is just magma at the surface, like in active volcanoes today, like Hawaii, etc., you get the rock cooling much faster, and you get rocks like basalt, where you can't see the same crystals that we can see in this rock. It just will look like a dark matrix, but that is also igneous rock. So what is igneous? It is rock that is basically frozen magma. So the second rock type that we are looking at today is sedimentary. Here is our mudstone. And this forms basically by the accumulation of sediments in a basin. So for example, the North Sea is a basin at the moment. We have rivers that flow into that area. Sediments are being deposited. You get buildup of sands along shores, and Aberdeen Beach is revealing some fascinating things to us at the moment because the erosion of some dunes is happening. And so you can see sand formations in unconsolidated sand that is just being eroded away, but you can see what the structures would have looked like if this was buried deeper and lithified. And so here are some photos of other sandstone formations. Here's Stag Poly, some of the sandstones at the top of this hill, and you can see similar layering and bands of coarser grains from stronger water flow. And here's us at the Gardenstone conglomerate, which is a mass debris flow. So it seems likely that this would be offshore, and you basically get an underwater mudslide. And the third and final rock type we get is metamorphic. And this is where you have an igneous sedimentary or even metamorphic rock. You put it under a lot of pressure and temperature, and a rock gets transformed. And it can be either just in its shape, or it can be partially melted and re-crystallize, but that is a metamorphic rock. So you may be thinking, Ben, where's the cycle? And the answer to that comes in three parts, namely weathering and erosion, total re-melting and re-crystallizing, and burial and partial melting, or if you like, smashing, melting, mashing. When you have any of these rock types, they can be weathered and eroded, and the grains and the broken up bits of rock will get transported by water and air and taken to sedimentary basins where they will get lithified, and that is how any of the rock types can become a sedimentary rock. And so how do all the rock types transform into igneous rocks? They basically have to be completely melted. And so the main way that this happens is through subduction of plate tectonics, where, for example, around the Pacific Ring of Fire today, subduction of the Pacific plate, and basically all rocks can melt completely if they get heated to the temperatures that there are within the Earth, and then when they recrystallize again at a point where the temperature is less high near the surface and a lower pressure, you get crystallization of fresh igneous rocks. So how can a rock become a metamorphic rock? And well, metamorphic rocks are completely dependent on there being existing rocks, but basically through giant plate tectonic collisional events or through intrusions of magma, you have heating of the country rock, which is the bit surrounding that intrusion, and the minerals in that rock can melt and recrystallize as different minerals, and this would be a metamorphic rock. But sort of the large scale, most common form is through these large tectonic collisional events, mountain building, where you get extreme pressure put on rocks and they will be mashed and transformed and folded, and that's how you get metamorphic rocks. Thanks for watching, hope you've enjoyed this video. Keep rocking.